Hello. In this video, we're going to talk about a shortcut on how to do derivatives. We've talked about how to do it the algebraic way, which is kind of long, but you can appreciate how to find the derivative function. And I've also shown how to do it in the calculator, but there is a shortcut I'd like to show you. And the shortcut is based on the long algebraic way. So please understand, you need to understand the algebra to understand why the shortcut works. So if I had the function x squared, and I did it the algebraic way, plugged in x plus h into the function, minus the original function, simplified, cleaned it up, was able to plug in 0 for h, you would get 2x. There's your derivative function. So because of this process, we examined it, and found a shortcut. So the shortcut, again, only works because of the long way, the algebra way. So what happens is, if you follow the power rule, the exponent goes to the front and you subtract 1. It's always the exponent goes to the front and subtract 1. If you have a number in front, then the number in front stays. We'll talk about that. So how did I get from x squared to 2x? Well, the algebra is all here on how to go from x squared to the derivative function of 2x. But the shortcut says you take the exponent, move it to the front, and then subtract 1 for the derivative of 2x. A lot faster. So here's some examples. I'm just going to walk through them with you. If you had x to the third, what would be the derivative function? So my original function is f of x. Remember, my derivative would be f prime of x. That's why I can know this is my derivative, this is my original. 3 goes to the front, subtract 1, 3 minus 1 is 2. Your derivative function is 3x squared. If you did it the algebraic way, you'd get the same answer. If the original function is x, remember that's like x to the 1. The 1 goes to the front. 1 minus 1 is 0. X to the 0 is 1. So you're left with just 1. What if you had a number like 5? What's the derivative of 5? Well, you can kind of think of it as if this was x to the 0 because there is no exponent. 0 times 5 is 0. Bottom line, the derivative of any number is 0. Now, if my original function was 1 over x squared, moving it to the front, subtracting 1, it's not ready. Sometimes we have to rewrite it so it's easier to work with. So hopefully you remember your exponents, and remember that 1 over x squared is the same thing as x to the negative 2. 1 over x squared is the same thing as x to the negative 2. Now that we know that, the negative 2 goes to the front. Negative 2 minus 1 is negative 3. And then I can simplify it by taking the negative 3, move it to the denominator, and it becomes a positive 3. So my derivative function would be negative 2 over x to the third. Again, sometimes we need to rewrite it so we can understand it. So if I had the square root of x, that's the same thing as x to the 1/2. X to the 1/2. Now that we've rewritten it as x to the 1/2, the 1/2 goes to the front. 1/2 minus 1 is negative 1/2. I can rewrite it as 1 over 2, and then the negative 1/2 can be square root of x in the denominator. Generally, we don't want square roots in the denominator, but just to give you some practice rewriting. Now, in the next example, the function equals 6x to the 4th. Notice there's a number in front. The number in front stays in front. So the 4 goes to the front. 4 minus 1 is 3. 6 times 4 is 24. X to the third. Now, d over dx means the derivative with respect to x. It's another way of writing it. So instead of saying f prime, I could put d over dx. And then, what if we have things that are being added and subtracted? So I had a series of terms. So for example, what if I wanted to find the derivative of x squared minus x to the 4? Well, I would just treat them separately. The derivative of x squared would be 2x. Minus the derivative of x to the 4 would be 4x to the third. And as we discussed before, if there's a number in front, it stays in front, and you take the derivative of the part that has the exponent. So the 7 would stay in front, 3 would go to the front, 3 minus 1 is 2, 7 times 3 is 21x squared. And we can also talk about why this works when we deal with multiplication soon. Okay, so there's a couple more examples here. If I wanted to find the derivative of the function 3x squared plus 2x minus 4, the derivative of 3x squared, 2 goes to the front, 3 times 2 is 6. 2 minus 1 is x to the 1. The derivative of 2x, 1 times 2 is 2. 1 minus 1 is 0, so there's no exponent there. So it's just 2. And the derivative of a number is 0. So your function would be 6x plus 2. If I had a little longer, like a function negative 7x to the 4 plus 3x to the 5th minus 2 over x to the 3rd minus 4x plus 3, I would rewrite it first. So here's my original function. I'm rewriting my original function because I like the number in front, variable exponent, number in front, variable exponent. When there's a variable and exponent in the denominator, I want to rewrite it. So it'd still be minus 2. X to the 3rd brought up would be x to the negative 3 minus 4x plus 3. So remember, I'm rewriting it. I have not taken the derivative yet. Now, notice derivative prime. That's my derivative function. 4 times 7 is negative 28, x to the 3rd. 5 times 3 is 15, minus 1, x to the 4. Negative 3 times negative 2 is positive 6. Negative 3 minus 1 is negative 4. Derivative of negative 4x would be negative 4. Derivative of 3 is 0. And then I prefer not to have negative exponents, so the negative 4 goes to the denominator, and I just rewrite it. Okay, so again, to make life a little easier, rewrite it. Next one. If I had the function 2x over 3 minus 6 over x plus 2 over 3 x to the 0.2 minus x to the 4 over 2, it really needs to be rewritten so I can clearly see what I'm doing. Take the time to rewrite it to make life a little easier. So I'm rewriting the original function, not the derivative. 2 over 3 would be 2/3 x minus 6. This is x to the 1. When I move it up, it'd be negative 1. Plus 2 over 3. X to the 0.2 is in the denominator. When I move it up, it'd be a negative 0.2. Minus, this is 1 over 2, x to the 4. This is a rewrite. It is still the original function. Now I take the derivative. The derivative of 2/3 x is 2/3. Negative 1 times negative 6 is positive 6. Negative 1 minus 1 is negative 2. 2/3 times negative 0.2 is negative 2 over 15. Negative 0.2 minus 1 is negative 1.2. 4 times a half is 2. 4 minus 1 is 3. And then any negative exponents I would move down. So my derivative function would be 2/3 plus 6 over x squared minus 2 over 15 x to the 1.2 minus 2x to the 3rd. Now, could be some interesting ones, like for example, if you had x to the 1/3, 1/3 goes to the front, 1/3 minus 1 is negative 2/3, negative 2/3, move it down to simplify, 1 over 3 to the x 2/3. It works for fractions, decimals, doesn't matter. And then be careful, sometimes you can plug in 0 to the original, or a number into the original, but not into the derivative. So for example, I can plug in 0 into the original, but I cannot plug it into the derivative. It would be undefined. And then there's some weird ones, for example, the absolute derivative of an absolute value function. You basically, to take a derivative of absolute value, you rewrite it over x. Again, if you do it the long algebraic way, it explains why. So if I had 3 absolute value plus x, the 3 would stay in front. The derivative of absolute value is absolute value of x over x, plus the derivative of 1x is 1. In the next video, we'll be doing some applications.